this lesson is on the probability of compound events. A compound event is an event made up of two or more events that can happen either at the same time or one after another. These events can be either independent or dependent. So we have compound events. That means we have one or more event. They can either happen at the same time or one after another. Sometimes you roll one die and then you roll the other die. Sometimes you choose two students out of a classroom. So it doesn't matter if they're happening at the same time or one after another. So let's talk about these compound events. We said we can break them up into two groups. We've got the independent ones. And these are events where one event does not affect the other event. A good example of an independent event is rolling two die or flipping two coins. When you roll a die and then you roll it again, does what you get the first time affect or change the outcomes that are possible on the second event? And they don't. You have a 1 through 6 the first time and 1 through 6 the second time. The same with coins. You can always get heads or tails. But with dependent events, it's a little bit different. The first event does affect the other events. So we might have something like, if I choose a student out of a classroom and then I choose another student, because that first student was already chosen, it changes the probability of what can be selected the second time. So let's look at a couple of different examples. We'll talk about the probability of independent events first. And to find the probability that A happens and then B happens, we find each of their probabilities, the probability of A and the probability of B, and then we multiply those probabilities to find the probability that both of them happen. So let's suppose we have a number cube with faces numbered 1 through 6. I like to go ahead and write my numbers down so I know what I'm dealing with. So we have the numbers 1, 2, 3, 4, 5, and 6. And then we have 5 cards. The cards are red, green, yellow, blue, and black. So we have red, yellow, green, blue, and black. And we're going to roll the number cube once, and then we're going to draw one of the cards. So what's the probability we roll a 2, and then when we draw our card, it's not blue? Well, the probability of rolling a 2 is 1 out of 6, so that's 1/6. The probability of getting not blue. We have 4 colors that are not blue: red, yellow, green, and black. So the probability that happens is 4 out of 5. And we're going to multiply those two together to get our probability. We always want to simplify first. We know 4 and 6 are both divisible by 2. 1 times 2 is 2. 3 times 5 is 15. So the probability we roll a 2 and then draw a card that's not blue is 2 out of 15. If we had made a tree diagram, we would have seen that there were 30 possibilities, and of those 30, 4 of them were a 2 and not a blue, because we know we could get a 2 and a red, a 2 and a yellow, a 2 and a green, a 2 and a black. If you have the tree diagram, you want to use that, but this is going to help us when the numbers get much larger. The next one is probability of rolling a 6 and then drawing a white card. Probability of rolling a 6 is 1/6. Probability of drawing a white. Well, we see there are no white cards, so that would be 0. 1/6 times 0. There is a 0 chance that we're going to roll a 6 and then draw a white card because there are no white cards. We know that means it's never going to happen. The last one, we want to roll a 2 or a 3, and then we can pick any of the 5 colors. The 2 or 3 is what we talked about yesterday. The probability of rolling a 2 is 1/6, plus the probability of rolling a 3, which is 1/6, is 2/6 or 1/3. The probability we draw any of those 5 colors is 1. We know we have to get one of them. So the probability that we roll a 2 or a 3 and then any color is 1/3. Now let's talk a little bit about dependent events. We said that the first event affects the second event. So with this, once you find the probability of A, you find the probability of B after assuming that A has happened. So we're going to find each probability. If you pick a card, do not replace it, and then pick a second card. What's the probability of first picking a black? Well, there's 1, 2, 3, 4, 5 black cards out of 8. And then we assume we did draw that. So now let's say this card is no longer in the pile. Now we have 3 white cards out of the 7 cards there are. So 3 out of 7. We can't simplify there, so 15 out of 56 is the probability that we're going to draw a black and then a white. For a black and then a black, we're going to put all our cards back in the pile there. The probability that the first one is black, we said is 5/8. That hasn't changed. Now we take that card out. Now we only have 4 black cards. 1, 2, 3, 4. So the probability of drawing a black has changed to 4 out of 7. I'm going to simplify before we multiply. So we get 5/14. A couple more examples. John's batting average is a .354, which means the probability of him getting a hit on his next at bat is .354. That's the probability. So we're just dealing with probabilities as decimals instead of as fractions. What is the probability that John will get a hit during his next 2 at-bats? So we're looking for both of his at-bats that are coming up to be hits, and we're going to ignore the change. There ought to be a little bit of change in his batting average if he gets a hit the first time, but for this example, we're going to ignore that change. So the probability he gets a hit is .354. So the probability the first one is a hit is .354, and the probability the second one is a hit is also .354. We could also write that as .354 squared. When we multiply that out, we get 0.125316, which is about 12.5%. That's the chance that his next 2 are going to be hits. What if we wanted him to miss? What would be the probability of him missing? Well, we know that these are complementary events. Hitting or not hitting, it's got to be one or the other. So if the probability that he hits is .354, if we do 1 minus .354, the probability of him missing is .646, and so we would just use that number instead. Okay, in my class, this is our last example. In my class, I have 4 girls wearing solid green skirts and 5 girls wearing plaid skirts. If I randomly choose 2 girls from my class, what is the probability? And we're going to look at 2 different things. The first one is that I choose 2 girls wearing solid green skirts. This is going to be a dependent event because who I choose first affects who I could choose second. I'm going to go ahead and draw out what we've got here. We've got 4 girls wearing solid skirts, and we've got 5 girls wearing plaid skirts. I want 2 girls wearing solid green skirts. The probability that the first one is wearing a solid green skirt is 4 out of the 9. And then we assume I do choose that girl. And so now the probability the second one is also wearing a solid green skirt is 3 out of 8. We'd want to simplify first before we multiply. And we get 1/6. The last one we have, what's the probability we choose a girl wearing a solid skirt and then a girl with a plaid skirt? So the probability that the girl was wearing a solid skirt, putting this girl back in, is 4 out of 9. Then we assume she's chosen, and the probability of drawing a girl with a plaid skirt is 5 out of the 8. Simplify. And the probability that that happens is 5/18.